kids on. We're building on that. And now what we're going to do is we are going to take an equation that has how many zeros? How many zeros? 3. And I'm going to find all of the zeros without being given any suggestions of which, what one was. Remember that's what we were doing before, as I told you one or two of them. Now you're going to find out. So our first step is we're going to take, out of, how many numbers are there total? How many? Infinite. We're going to take out of the infinite many numbers, and we're going to narrow it down to just a few possible choices that could be zero. Actually, that could be rational zeros. This only works for rational numbers. Rational has the word ratio in it because it's any number that you could write as a fraction, like A over B. A over B could be like 4 over 2, which is actually 2. And possible means, just because I write it down does not mean it is a zero. These are possibilities. We're going to find all the possible rational or solutions, or x-intercepts, or zeros. First thing you're going to do, and this was taught in algebra 2, so this should be a review. First thing you're going to do is you're going to take the very last number, the constant, and we're going to call that p, and you're going to find every single factor of p. So for 5, what factors are 5 and 1, also negative 1 times negative 5 makes positive 5, so we've got actually 4 factors. We've got plus minus 1 and plus minus 5. And we're going to do the same thing for what we call q, which is going to be the leading coefficient, 42. So for q, we can have plus minus 1, plus minus 2, plus minus 3, plus minus 4, 6, 7. 4 is not 1. My bad. I'm just like going, not thinking. Okay. Plus minus 14, plus minus 21, and plus minus 42. A few more q's. And using these numbers, if we put p divided by q, every single possibility of p divided by q, we will have any possible rational solution. We won't find any irrational or imaginary ones, but we'll have every possible rational solution. So just start with one of the p's and put it over all of your q's. So I'll start with 1. Put that over all of my q's. So 1 over 1 is 1, plus minus a half, plus minus a third, plus minus a fourth. Nope, not a fourth. Really want to do that. I don't know why. 6. Okay. And then I'm going to put 5 over all of these p's. So plus minus 5 over 1 is 5. Plus minus 5 over 2. So we have a lot of possible rational solutions. There's only 3. We have a lot. There's 32 of them. But that just took it down from infinite to many. So we got rid of a lot of them that aren't possible rational solutions. Now, I'm teaching this as part of your curriculum to know how to find the possible rational solutions. After that, we're not going to use it. What we're going to do is, since we do have technology, is we're going to next type this equation into the calculator. So go ahead and take out your graphing calculator, type that equation in. Graph it. I'll put mine up there so you can see if it looks the same when you graph it. If your graph looks all funky, maybe hit Z6. Otherwise, maybe you typed it in wrong. And do I have any errors you can help with? Okay, the advantage of technology. Before the technology, we would have to, and this, I'm saying we, I happened after technology. I had graphing calculator in high school. So back in the day, before graphing calculators, you would have to take each number, and there's 32 of them, and start using synthetic division or long division and divide out to see if it was a factor. And if it ended in a 0 when you divided it out, you knew you got a factor. We got 32 numbers. That could take a while if the last number you choose is that factor. So now that we have this technology, you're going to look at the graph and you're going to say, what do you think one of the factors might be? Or zeros. What do you think one of the zeros is? Okay, let's see if -1 is a 0. So next on your paper, we can use -1 with synthetic division. We're going to do synthetic division. And if you get a remainder of 0, then you know for sure, yep, it's a 0. Once we get our equation, once we take out enough factors, that what's left is quadratic. You can then use quadratic formula, or you can use factoring. You can complete the squares and finish it. So since we started as a cubic, I only have 2 more factors to find. That's when we're going to rewrite this equation and finish solving it with other methods that we've learned. So your choice. Do you want to try factoring to see if it works? Do you want to do quadratic formula, or do you want to do complete the square? Factoring might work. The other two always work. Here's something. Try it in the future. Define what x equals. Your choices are factoring, quadratic formula, or complete the square. You think what? Yeah, it's plus 5. Why is there a minus sign? Thank you. Well, do we need to sing the song? We need to sing the song, don't we? X equals opposite b plus or minus square root b squared minus 4ac all over 2a. It worked. X equals opposite b plus or minus square root b squared minus 4ac over 2a. This one's factorable. So some of you doing it by quadratic formula. This one's actually factorable. What'd you get? This? Or minus 1. I was trying to hear what you said, but it didn't register. That's a factor. Okay, if you're doing quadratic formula, you should get the same exact answers that I get. I've factored it I'll find the answer 7x minus 1 equals 1/7, and 6x minus 5 equals 0, so x equals 5/6. I don't know why I wrote that, I'm sorry. I'm like thinking ahead. X equals 1/7, there we go. So I get 1/7 and 5/6. If you do it by quadratic formula, you should get the same answer. You do it by quadratic formula, so that's the answer. The directions are saying to rewrite this in factored form. Nice, you do a bunch of that on the quiz you just took. And as I was walking around, I saw a lot of people writing the factors, but you forgot part of the factored form, which is how you know it's an equation. Make sure you have like f of x equals in front of your factored form. And then we write our factors. The first factor comes from us having a 0 of -1. Which factor gives us x equals -1? The next one is x equals 1/7, but my factor is not going to have a fraction in it. So if you did it by factoring, then you already have 7x minus 1. If you didn't do it by factoring, you're going to have to multiply both sides by 7 to get rid of that fraction, to get rid of the denominator, and then add 1, or subtract 1. And then the last one would be 6x minus 5. And eventually we're going to be using that information and graphing it and doing all the other questions that we've been doing, finding the y-intercept and looking at multiplicity and all that fun stuff. All right, next one. Everybody heard me about right small? Next one's not so bad. The third one has a lot of work. All right, B. We're going to first start with finding all the possible rational solutions. So we take P over Q. My P values, plus minus 1, plus minus 3, plus minus 9. We have 6 values for that. And then my Q values, just plus minus 1. So when I do plus minus P over Q, I'm going to have plus minus 1, plus minus 3, plus minus 9. I'll put each of them over Q. So that says there's only 6 possible rational solutions. And how many solutions am I looking for? How many factors am I going to have? 4. Here's 6 to choose from. But remember, these are the rational ones. There might be irrational answers, or there might be imaginary answers. So we're only going to know that by you guys graphing this. Go ahead and type it in your graphing calculator. Graph it. And then I've graphed mine up there so you can see if it looks the same, you probably typed it in correctly. If not, maybe you made a mistake. And then if you think you see a 0, use synthetic division and take it out. Oh, you draw it there. It's fine. It works. You draw it differently. All right, what number do you think I should take out with synthetic division? -3? All right. You guys are doing the same thing on your paper? Should be ahead of me. Take out -3. Is it a factor? Or a 0? Yes. Once we took that out, how many are left? 3. So at this point, I'm not going to be able to use quadratic formula and find the other 2. It means there's another one I should be able to find on my graphing calculator. We look back at the calculator. Is there another 0 that we could possibly find? Tell me.
It doesn't pass through.
At -3, it doesn't pass through. It bumps off of it. So that means there are a multiplicity of 2. So we know there should be 2 -3s. So my next step is I'm going to take out another -3. So we're going to use multiplicity. That's why we were learning about it. Woo, and it worked. So once I've taken out 2, now I have a quadratic. Inside that quadratic, my choices are factoring quadratic formula or complete the square. And I'm always going to go to factoring first. Will I be able to factor this with a 1 on the end and a 5 in the middle? So factoring's out. I'm left with complete the square quadratic formula, but if I look in the middle and it's a 5, I want to do complete the square for this one. If it were a 4, I'd do it with a 5. So I'm just going to do quadratic formula. X equals alpha to b plus or minus square root b squared minus 4ac all over 2a. X equals -5 plus or minus square root of 21. Now the goal is to write this in factored form. So I take all of my zeros and write them as factored. This one is g of x. My first factor comes from -3, so that'll be x plus 3. But how do we show that there's 2 of them? Do I write 2 of the x plus 3's? I'm going to write squared. Now, the next 2 factors come from this. This is a fraction. Am I going to have a fraction down here? Actually, you know, that's not how, I taught it that way in the other class, and now I'm thinking about it. I am going to have a fraction, I think. I'm sorry. I'm just totally remembering something off the top of my head. The leading coefficient is a 1. If I try to get rid of this fraction, this is what I did in my other classes. I wrote this as 2x equals -5 plus or minus square root of 21. If I were to write that as 2x and I have like each of these starting as 2x, when I multiply it all together, I'd have like 4x squared or 4x cubed in the beginning, 4x to the 4th. If I have a 2x here, that's not going to work. So I'm going to leave it as a fraction. So never mind about that. It doesn't matter, it's a fraction. Okay. Okay. So I just need to set this so it says x something something equals 0. I need to make it say equals 0. So how do I move this to the other side? How do I move this entire thing to the other side? How do I move this entire thing to the other side? No. Add's not the right answer, but you're closer than multiply. How do I make this side say 0? Subtract it. So I'm going to subtract -5 plus or minus square root 21 over 2. Now I can get rid of these extra parentheses by distributing that negative sign. So that is going to become a +5 here. And then when I distribute the negative sign to a positive, it becomes negative. When I distribute it to a negative, it becomes positive. So this is still +9. You do need to write the factors separately. So I'm going to have x plus 5 plus square root 21 over 2. We'll have x plus 5 minus square root of 21 over 2. That's like our other two factors. And if you multiply the first term back, x squared, x, and x, we should get x to the 4th. Just to make sure that we have everything in the right places. Okay, so that's factored 4. We've got one more question to go through. This is the one that takes a lot of space. So the p over q part for this next one, if you want to do the p over q on the back and then do the rest of the work on the front, that'd be fine. If you want to do the p over q on the front and do the rest of the work on the back, that's probably also fine. But I doubt you're going to fit it all on the same side. Or for C, for question C. So question P, if you want to flip it over and just do this P over Q thing on the back of your paper, our P values are coming from 120, and our Q values are coming from 12. So I did my Q values first just because they're smaller. I'll do my P value. So to check, if you have the right numbers, 1, 2, 3, 4, 5, 6, 8, 10, 12, 15, 20, 24, 30, 40, 120 for the P. We're going to do our plus minus P over Q. And I'm just going to do all the P's over the first Q. So I'm going with all of the P's over 1. All of them over 1. Now we put all of them over 2, plus or minus 2. But something will happen when you have big ones like this. Something usually happens. Like when I do plus or minus 2, I'm going to put 1 over 2. And my next one, I'm going to put 2 over 2. So if I put 2 over 2, what is that? That's 1, which we've already written down. I'm going to rewrite it. And I'm going to put 3 over 2. That one we haven't done yet. The next one is 4 over 2, but that's a repeat. So I'll have to write that one. I've got 5 over 2. Then I have 6 over 2, but that's a repeat. Then I have 8 over 2, and that's a repeat. Then I have 10 over 2, and that's a repeat. 12 over 2, I already have that one. 15 over 2 is new. 20 over 2 is a repeat. 24 over 2 is a repeat. 30 over 2, 40 over 2, 120 over 2. I've already written all of those down. So now we move on to the 3's. I forgot to write 60. I should have written it. Oh. Thanks, Charlie. But then that one becomes 30, so it's repeat. All right, now we're going to do all of these numbers over 3. So we'll have plus minus, oops, I changed colors, over 1/3, and I'll have plus minus 2/3. Then my next is plus minus 3/3, but that's 1, I already have that one. Well, plus minus 4/3. Plus minus 5/3. Plus minus 6/3, well that's 2, I already have that one. Plus minus 8/3. Plus minus 10/3. 12/3, I already have that. I'm not going to take class to make the entire list for you. And I didn't give you any that are that mess, okay? But what I wanted to show you is that if they repeat, don't repeat them. And some of them might be kind of longer. But all you have to be able to do is list these out, and like I said, I'll never put like that many. I'm not going to do that many. The next thing we have to do is find possible zeros, which will come from that list. But we're going to find them by using the calculator, so go ahead and graph it. And you're going to want to graph this one because I'm going to show you something else. And we haven't done yet with the graphs. So we're going to graph. If you have a graphing calculator with you. Okay, where do you think a possible rational zero is? Maybe 1.5? Maybe. And let me show you, if you're unsure, how you can find the zero. So go to the calculate button, second trace, and we're going to push 0. You doing it with me? And it says left bound. Which one were you thinking? Charlie, I'm sorry. I already forgot. 1.5? Okay, so if we think it's 1.5, let's pick something to the left of 1.5. That's 0, enter. And then something to the right of 1.5. So 2, enter. And then guess. We were guessing it was 1.5. Enter. Was it 1.5? Yes. Okay. So since it's 1.5, I'm going to use that as a fraction. I'm going to use that as a fraction. What is the fraction of 1.5? 3/2. We're going to say that x is 3/2. So that's one of our zeros. And then when we go to divide that out, if I write this as a factor, I can't have fraction. So if I write this as a factor, it's 2x minus 3. And if it has a 2 in front, what am I not using? I'm not using synthetic division, I'm now using long division. Sorry. So 2x minus 3, we're going to use long division to factor that out. So we divide, we multiply, subtract, run on down, repeat, divide, multiply, subtract, run on down, divide, what yes, -3, multiply, subtract, and that has a remainder of 0. So what's left is 6x squared minus x minus 40. Equals 0. So I have a quadratic. What are my options now? Factor it, or complete the square, which the center is 1, the middle term is 1, and not complete the square, or well, you know what? You might be able to. If it's irrational, or if it's a horrible fraction that you don't recognize, let me help you. And I want you to take it to quadratic and then show me no other methods of solving it. Keep that pressure in mind. So we've already gotten this far. We're going to use either quadratic formula or maybe factoring into factors. I do not remember if this one factors, so I'm just going to do quadratic formula. You guys have a calculator, so you're dealing with big numbers. It's okay. This one would be 1 minus 4 times 6 times -40 all over 2 times 6, so 12. 961. And 961 is a perfect square. Yay! So it was factorable. We get two answers. One of them is 8/3, and the other is -5/2. And I did that really fast, just for time. Okay? I'll leave this. Oops, I'll leave it up as soon as I'm done. But now you're gonna write it. You're gonna write it as a factored form. This one was called h of x. Our first factor was 2x minus 3. Was it? No, 2x minus 3. Now my next factor has to give me 8/3. So I'm going to multiply both sides by 3 and subtract the 8. I have 3x minus 8. And then my next one has to give me -5/2. Multiply both sides by 2. Add the 5. And then just double check. If I multiply together the first 3 terms, do I get 12x cubed, like the original question says? If not, then something's wrong. Your assignment is a worksheet. I'll leave that up if you're still copying. Your assignment is a worksheet. And we're not going to see each other until Tuesday. So lots of time to complete this 7-question worksheet. On Tuesday, we will finish 2-5. And then we'll only have one more session left in this chapter. Seniors. Almost completed it.